Okay, so section 4. Section 4 is taking radicals and writing them differently. So back in the day when you were a little mathematician, you learned that these two are the same. This is called a decimal, and this is called a fraction. They have the same value, but look different.
Decimals.
You learned about repeating decimals and their fractions.
Never mind.
We don't do math with repeating decimals. We do math with fractions. We do this. And we get 1. We do this.
Holy crap, I never thought about it
and
like
we
that.
get
0.999 repeating.
not a thing.
What? I never.
False.
And that's why we don't do math with decimals. And that's why decimals are the devil.
I never thought about it like that.
I know.
3 1/3 equals 1.
Yes. So what I'm getting at.
Wait, what?
What do you think it
What do you
was?
think it
It's
was?
a pie.
I don't know. I just never really
And you
liked
have
fractions.
1, 2, 3/3, and that makes one whole pie.
Wait, but
Pumpkin.
0.3 repeating.
Nah,
does not
I'm more of an
equal
apple
one.
kind of
Apple
guy.
pie had
Together,
both.
it-
My
Oh,
apple
apple
pie
pie
more
is so
turned
much
into
better.
like an apple
Mush.
tart, more of a cobbler.
Oh yeah, and also.
When the pie fails, you just call it cobbler, and everyone's like, yeah, okay, cobbler.
Well,
All right, so
and then pecan.
what I'm getting at is we have decimals, we have fractions. They both have value, right? If you're at the gas station and you fill up your tank and it's going to cost you $19.3333, obviously we chop it off and we get $19.33. There is value to repeating decimals, right? But there is also value to fractions. They make things more accurate and they make things make more sense, and we can do more math with them. So radicals are great, but there are times where they're not good enough. And we can do more with what are called rational exponents.
Let's be
So there's a
rational.
time and a place for both, and we need to know both. So a rational exponent, remember the word rational means you can write it as a fraction of 2 integers. So a rational exponent is basically a fraction exponent. Does that make sense? So your exponents are going to be fractions. Here's how you create the fraction. There will always be a power of your radicand, whether it's 1 or 17. There's always going to be an index, whether you see it or not. Okay? If you don't see it, it's 2. If you do see it, then it's whatever is there. You're going to create a fraction exponent. So I know this kind of looks weird, but it's supposed to be an exponent, by taking the power and putting it over the index. So quick example, square root of x. There's a power there. It's hiding, but it's a 1. There's an index there. It's hiding. It's a 2. If I wanted to write the x with a rational exponent, I would write x to the power of 1/2. Power over exponent. Or power over index. And that is your exponent. Okay? Don't mix it up.
What's the index again?
Index is the tiny little number that is usually written here.
Ooh. Okay.
That tells you how many groups to make, and if you don't see one, it's always a
2.
because it's a square root. The most basic of radicals.
I think it's the hardest one. I'm kidding.
Okay, so now we're just gonna like practice doing that. So we have in here, we have an x, and he has a power of 5 and an index of 4. So this is gonna be x to the
5 over 4.
power. Ta-da!
It looks so ugly.
Now, I know. Now, just a side note, you could also write this like this.
Oh.
So
Does that mean the
it's
same thing
important
though?
to know both.
Interesting.
Yeah, it's important to know both. So whether the power is right next to the radicand,
Oh, that's an
or
X.
if the whole thing is raised to a power, it's still the power. So the index, no matter what, goes in the denominator, and the power, no matter what it looks like, whether it's inside or outside, the power always goes in the numerator. Okay? All right. So like this. So we're going to do a to the what power?
6/3 or 2.
Right. Now, if you think about it like visually, this means I have 6 cube roots of a. Oh, jeez, that's so many cube roots of a. has 6 cube roots of A. If I have 3 of them, that's an A. If I have 3 of them, that's an A. And when I put them together, I get,
A squared.
there you go.
So that's so fast.
Makes sense.
I'm
Wow.
not letting anyone say it in front of me.
All right, now, when they're both together, that's okay. Remember, when you have multiple things inside of a radical, you could look at them separately. So that's what we want to do here. Look at these guys separately.
So the 5 only goes in the last one?
Yes, because it was on the 5, not on the x. So different, if it had like parentheses around it, then that would, the 5 would be associating with both of those guys, but he's not. So this would be x to the what?
One half.
1/2.
Oh yeah, whoops.
Remember, that doesn't make sense. Yes. And this one would be y to the 5 halves.
I don't worry about why.
Okay, index goes on the bottom. And that's
Why?
it. Ta-da.
Oh.
Questions?
Is this recorded?
Yeah, I'm recording. And I post it.
No, Luke, she's not recording at all.
Well, don't you usually just post another class? Because every time I watch, it's someone else's class.
I just mix it up.
Oh.
You and 7th usually.
Yeah. What's your one for your
Third period's all we love third period.
No, we
My
don't.
faves.
No one loves third period.
We're still recording.
That's okay. They know I love
Third
them all.
period, you suck.
They don't watch the videos.
Mary Ellis is in third period. I always walk by and like look at
Mary
her.
Ellis, you
videos?
suck.
I don't know if she watches the
Oh, you
videos.
walk by the class.
Like I walk by the class and I just see her and I'm like,
And you're like,
hey.
all right, so now we're gonna go the other way. So we have rational exponents, and we're gonna go the other way. Now, if you type this on your calculator, it's gonna give you the answer, which is nice. If you don't have a calculator, you have to figure out how to know what that number is. And by putting it back into its radical form, you can figure out what that is. So we have 216. I'm gonna put a radical here, and I'm gonna put in an exponent and then an index. Which number is the index?
Definitely the whatever that is.
3. Now, listen, it has to be 3 because 1 is never an index. That doesn't make sense. So
What?
use your intelligences. 1 would be the exponent. We don't really need the exponent there. I stuck it there. I'm going to take it away. It's just dumb. We don't need that. So what I really am asking for is the cube root of 216. Now, you may know what the cube root of 216 is. You may not know what the cube root of
Oh, it's
16
actually a
is.
cube root? Darn.
Yes.
Oh, you're
Well,
dumb.
or it might not be perfect,
Isn't it
but
like 46?
it is 6. Well, let's say you don't know. What goes
Wait,
into
it's 6?
216?
How did you know that?
Because it was in the homework yesterday.
Oh.
Because we've done it a few times actually. Like when you see it a few times, you start remembering it.
Never.
But let's say we don't know it. What goes into 216? 2, and it goes in.
113.
We don't talk about that.
What?
Okay.
Oh,
yeah.
108.
108.
Oh, look, Emma. What goes into?
9 and 12.
Yeah. And 3 and 3, and 3 and 4, and 2 and 2. All right. So remember, we're looking for groups of 3. We have 3 3s, and we have
And 3, 2.
3 2s.
That
And what
was
does that
cute.
make?
A
6.
6.
6.
Oh, wait.
Wow.
I literally just was gonna put 6 to the third, and then I was like, wait, but.
When you're keeping it,
I was
and
like,
you
wrong.
just get 6.
That is wrong.
Oops. It's not 113.
Okay. Ta-da.
You love math.
Fun? Yes.
Yeah, I guess.
Sure. All right. Let's look at the next one.
I actually enjoy this so much.
So negative 32 to the 4/5. So we're gonna have
5.
negative 32 and then a radical. Now, where should we put the 5?
Outside.
I don't know.
Yeah,
man.
outside in the
Where should we
index.
put the radical?
Now, you can either put the 4 here or here. I'm putting it here for a reason.
It's
Do
easy.
you know what 32 to the 4th is?
No.
No.
You
By
kidding
putting
me?
it on the
No.
outside, it's going to make this easier because I do know what the 5th root of negative 32 is, and it's a small number.
Is it 2?
It is
0.5.
negative 2.
Right.
What?
Wait.
Now,
I really just guessed an even number.
What?
It's
Yeah, it is
fine.
negative 2.
What?
Yeah,
What
it does
you
make sense.
saying?
No, I think about it.
you lost me,
Two
Mr.
times
All right, what goes into
negative
32?
Definitely a
16 and
16
4
and
and
2.
8.
16 and 2, 4 and 4, 2 and 2, 2 and 2.
Afraid.
Okay, look. 1, 2, 3, 4, 5.
Oh.
And it's negative.
I think I'm just dumb, Miss Rep.
I think guys, we found the diagnosis.
And so, do you know what negative 2 to the 4th is?
No.
I do.
Yeah.
I don't.
You guys are
Oh,
such
wait,
silly
16.
gooses. You guys are such
2
silly
times 2
gooses.
is 4 times 2 is 8. Oh.
And so, therefore, that is a lot easier than doing 32 to the 4th.
Yeah, come on.
figuring out what the heck that is, and then fifth rooting that giant number. That would take forever. That's bad. So there is a time and a place, whether you want to put the 4 here or here. Play it out.
It's not time to
Yeah.
use your best.
Now, C, if you look, the exponent is negative. So most people, just in general, don't do the whole negative exponent thing right. I don't know why. It's like something you're supposed to learn in Algebra 1 and like no one knows it. So look, observe. Negative exponents. X to the negative 1 is the reciprocal of x. X to the negative 2 is the reciprocal of x squared. X to the negative 3 is the reciprocal of x3 cubed. X3.
Oh, the reciprocal. I was like listening to you speaking, not comprehending.
Okay.
But now
So what you're saying is
Going the other way, 1 over x squared, or 1 over x to the negative 2 power is the reciprocal of that, which flips it back up. 1 over x to the negative 3 power is positive x
So is
cubed.
that positive 2 or 5?
So what we're going to do here, so this says 16 to the negative, what does that say, 5?
5 over 2.
It's so small. Alright, so negative 5 over 2. So what we're going to do is take the reciprocal of 16.
So 1 over negative 1 over 16.
No, you're not making it negative, you're just taking the reciprocal.
Oh.
Okay, just taking the reciprocal. So that takes care of the negative part of the exponent. So listen, negative exponents don't make anything negative. They make them reciprocaled. This is when you make up math words.
Oh yeah.
It's like reciprocated is not what I'm trying
I'd
to
rather
say.
say reciprocated than reciprocal.
I know, because that's an
She just
actual
put
word, but it doesn't
reciprocated
really
in
make
the
sense here.
vocabulary.
Oh, then we could say
Reciprocated.
reciprocal. No,
Oh,
reciprocate.
Reciprocated.
Define
Yeah,
reciprocate.
like
When you
the
flip
past
it-
tense verb of reciprocate.
Oh,
But we're not doing that. We're finding the reciprocal, and that's different because
Oh.
it's math, and there isn't a word
oh,
for.
then it's reciprocalating.
There is no word.
There is no verb for reciprocal, so I make it up.
I like
Oh.
reciprocate.
Yeah, reciprocalating. That's like.
We have created a new word.
All right. So, anyways,
Put this
The
in
the
dictionary
first thing
dot
you're gonna
com.
do when you see a negative exponent is find the reciprocal. Then you're gonna deal with it from there. So now we have 1/16 to the 5 over 2 power.
Can you put a fraction into radical?
Yeah, we've been doing that. That was your homework last night.
Oh my god, yeah, what?
If you did your homework last night, you would understand.
So what
I
is
did,
the
I swear.
index?
It is.
2
2. So I don't need to write it, and then I'm gonna do
times 5.
to the 5th power.
The awesome.
Oh
Not
my
times
god,
five, that's
it's
different.
1 over 4.
So the square root of 1/16 is 1 over 4.
Sure.
But now we need to raise that to the 5th power. So 1 to the 5th power is 1.
Right.
4 to the 5th power is
Wait, a 1.
so like 2 4s is 16, another 4 is 64. Then we got
Just use a calculator.
To be honest, I'd rather
so
just leave it at that.
256, and then you're just doubling it. So what's 256 doubled is 512. Doubled again is 1024. Didn't you play that game?
What?
Okay.
What?
How do you do that in your head?
Oh,
Did you ever play like 2048?
2048.
I don't play
Yeah,
math games.
yeah.
Yeah, I know
2048, yeah.
So 2048 is just all the 2s, and 4s are basically 2s in disguise. So all I'm doing is doubling
How
it.
do you
So
play
I
that
did the
game?
first 2, right? 4 times, so look, like this. Okay, so 4 times 4 is 16. If you double it
64.
twice, that gets you the next one. So double it is 32, double it again, that's 64.
Oh,
Then double it, 128, double it, 256.
it's like the Doge
Then
one.
double it, that's 512, double it, that's the 1024. I'm just doubling a
There's-
lot. And I'm good at the doubling part because of that game.
There's
20,
something.
we love 24.
There's
Wait,
something
so
similar
is
to
it-
that, but it's about a Doge, and there's like pizza Doge.
Alright, so in order to
yeah.
simplify this,
I
you
had
have
it
to,
right.
it has to all
You
be
set me up.
with rational exponents. You can't like mix and match radicals and rational exponents, just like you can't mix and match like fractions. Like you can kind of in your head, but there's no like mathematical way to do this math.
You don't
There's
know.
not really a way.
Convert
If you,
it.
yeah, you're converting it. So whether you're doing it in your
Something to a
head
cult.
or whether you're doing it on the paper, there's not really a way to do it. So that's what we're gonna do here. We're gonna convert this to a rational exponent. So instead of writing x, y there, we're gonna write x to the 1/2 and y to the 1/2. Now, in general, I like to simplify from the inside out instead of the outside in because I think it makes it easier. So keep in mind we also have a power of 1 right here. And so instead of having like multiple x's, I'm gonna make one x by combining these two. So in order to combine those, you're supposed to add them. Yeah.
Why is it 1/2? Shouldn't it just be 1?
No.
So you have the square root of x and y, which is this.
How much writing
And this
am I
one's gonna be
doing?
1/2, and this one's gonna be
It's
1/2.
aggressive. But it's a small
And the index is 2.
If the index is 2, shouldn't it just be 1 instead of 1/2?
That would just be a regular x, think about it. If you just had x to the
Doesn't
1,
it
that
work?
wouldn't be square rooted, it would just be like a plain x.
Oh.
Does that make sense?
Would the x's become 3 over 2?
Yeah, so you're gonna add 1 plus a half, which is 1.5, aka 3 over 2. Okay. 1 plus a half. Does everyone know what 1 plus a half is?
1 plus a half.
1.5.
0.5.
Is 3 over 2.
Oh.
Did I teach you those tricks? I think I
I
taught
thought it was
someone
1 times a
these
half. I was
tricks.
like, that's 1/2.
I taught someone this trick.
What do you
If you
mean?
want to put like half numbers into fractions, you just double this number and put it over 2.
Whoa.
We double what number?
You double this number and put it over 2.
What?
I guess that makes sense, yeah.
It's like
Oh, yeah.
literally what you're doing. You're taking half of it. So if you double it and then put it over 2, you're finding the whole of the half. Yeah. Anywho, so if you don't know, if you know what 1.5 is, but you don't know what it is as a an improper, that's how you do it. Now,
Improper.
when you have like a bunch of stuff raised to a power, you're going to do something sort of like the distributive property. You want to apply that power to each term within the parentheses. So what you're doing is -8 to the 2/3 power. You're doing x to the 3/2 to the 2/3 power, and you're doing y to the 1/2 to the 2/3 power. So
I
you're
really hate small.
it's not the distributive property because you're not multiplying, but it's similar in the sense that you have to make sure that you raise each one of those monomials / terms to the 2/3 power. What?
Alright, so I understand when we're gonna have to use the stuff on the binomial radical expressions and everything I might be using like, but that when am I ever gonna need to use -8x?
Just think of it as a puzzle.
But here's the thing.
Navigate the puzzle.
But here's the thing.
No, wait. Here's the thing. I gotta finish this list.
Have you ever used that in real life?
Yes,
no,
she's a math teacher.
Well, yeah. I mean, I guess.
She's
That's
a
like
She's a math
teacher.
teacher.
outside of math class, I've not used this, but the skills that you learn in order to do this.
I will
To get
never
the
use
life
this.
rated.
Well, see, trust me. Now these
Problem
are fine.
solving.
I'm fine with these.
We're learning how to problem
But that-
solve.
Yeah, you're learning how to problem solve.
Yeah.
Once it
And
becomes fractions,
sometimes you
it's-
gotta do things you don't want to do.
Yeah, well, hey.
That's every
When
single
When we
thing
have to
you
know
ever
calculus in
do
real
within
life,
your
like he
life,
was like walking down the street and was like,
especially-
oh,
Calculus is like the explanation for everything in life.
Calculus
Really?
is like I'm
No,
not
but
going
lots
into
of
it.
things.
I'm not
Like
getting
what?
into
Like
calculus.
physics
Oh.
and statistics
Physics is
and
the
everything in
that really
between.
gets me.
What about
What?
pizza?
The fact that we
Divide a pizza equally
Alright, wait, I gotta go.
between
Alright, so
a group of people.
the rule for powers raised to power, so like this situation, powers raised to powers is you're supposed to multiply these. Okay? Do you
Do,
remember
like-
that from algebra 1?
What
Does
the
it become
heck,
one
Miss
and we
Rep?
have-
I can't do this. This is
That one's gonna be 1, so 3/2 times 2/3, those are reciprocal, so you're just gonna get x to the 1. Here, 1/2 times 2/3, you could like cancel the 2s and you get a third, yeah.
The -8 is a -12.
So then this part you have to like do math.
Oh wait, no, it's not.
So side note, we have -8 to the 2/3 power. Remember that's like -8 cube rooted and then squared.
So
Oh, it's
negative
4.
2 squared is 4.
Oh,
So 4.
oh my gosh! You put that in my head. Now I remember.
You put that
You can.
in my head.
So the denominator is the thingy that goes in
Okay.
front of the radical.
Denominator
then-
is the index.
The numerator is the power.
The denindex.
Second.
The
And then-
powerator.
Powerator or a num power.
Noom power.
And
Sounds
then
like a super.
and then dindex.
Can I put x to the 1? Can I put x to the 1 or is it not?
No,
Check
that's
the
awkward. Don't do
index.
that.
Oh, but I like it there.
Index here.
He doesn't like it there. He's an introvert and
He
he
can
doesn't
deal
like
with it.
being out.
Who doesn't?
He can deal with it.
Well, who doesn't like being out?
All right, let's try the next one. So the next
Me,
one has
that's
a
why-
negative exponent. So before you do anything, flip it.
I like going.
So we're gonna find the reciprocal of everything in here.
Oh my
Is
god.
that a Z?
That
That's
is
a-
a disgusting
What?
problem. That is the most disgusting problem thing I've ever seen.
Oh, just wait, there's more.
That's
What?
a really straight line.
It looks like a Star Wars spaceship.
Good with that one.
That's a good one.
Now,
H-wing
Do you
bomber.
see how the 8 is negative with the
Do we have to
y?
flip it
Straighter
again? I
than
swear
most
to God.
straight
So no, I'm just moving this
Straighter
straight.
than most straight people.
That's
So
good.
I'm just gonna move the y
That's
to the
straighter
top.
than me. Oh no, I don't want to admit
It's so straight that it's fabulous.
that.
What is going on?
So
So you
we're
can
moving-
bring one of
That
them
made
and
no
not the other?
sense.
Yeah, well that's the exponent for just the y.
I'm going.
So I can move just him. Now if it was, like, if you saw parentheses and there were other letters that were associated with that -8, then no.
Yeah.
But since that was just the exponent of the y, I can move just him.
These
So the reason we flipped the whole thing at the beginning was because the whole thing was raised to the negative exponent. So we flipped the whole thing at the beginning and now I'm just moving the y.
Because
I'm
the
a vegan.
Y is it.
Yes, but none of the other ones were negative, just the y. Alright, so now we'll do everything to the 3/4 power. So you're gonna do, now you don't have to write like this step out if you don't want to. I'm just showing you.
Do you have to do that line? Like a
You mean the fraction bar?
yeah. Do you have,
fraction bar is so necessary.
no, can you not do that though?
You can and you'll get it wrong.
Well,
It has to be there.
I might as well just start drawing like other Star Wars spaceships.
If that's what you want.
Alright, then we're gonna multiply these guys.
Golly.
6.
24 over 4 is 6.
So we have y
Might
to the
be killing
6.
me. I'm serious. I might be
Where
dying.
did you get the... Oh, I forgot to put the 8 there. That's my problem.
All right. This
Wait,
is.
so would Z just stay as Z 3/4?
Yeah,
Oh.
Yeah, unless you're not
just
cool.
leave that there.
And then Z's... Yeah.
Then we gotta do
12.
this. So, side note. What's the index?
4.
Is there a 4th root of 16?
Oh,
I don't know.
It's
2?
Oh,
And-
then 2 times 3, 6.
8.
No, whoa.
8.
Whoa, Madeline, whoa!
Wait a
It's
second.
such-
What?
2 to 6.
Hey, I was 2 off. Leave me alone.
At the end of the problem, you want to check a few things. So here are the things you want to check. First thing you're going to check. You should not have any negative exponents anywhere. If they're negative, you need to move them so that they're positive. So like, for example, Mr. -8, he was very unhappy down here.
Poor guy, he was depressed.
He was negative.
We don't talk about that.
We made him happy and positive by moving him up here. He likes being up here. He's
No,
more of
what
a
a
top
guy.
bunk kind of
More
guy.
alone.
Yeah.
Now,
But-
so that's the first thing you're checking. No negative exponents. The next thing you're checking is you shouldn't have a letter written more than once. So you shouldn't have like a Y here and a Y here. You shouldn't have a Z here and a Z here.
Will
Okay,
that
you would want to
happen in the
combine
simple
them.
How do we do that?
Can I have a W here?
We'll do that here.
Oh no.
You also shouldn't have more than one number unless it's like a fraction that can't be simplified. So for example, this is an 8. If we had a 3 up here, you could leave that. But if there was a 2 up here, you would want to simplify. So no fractions that aren't simplified. Question.
Never mind.
Question.
Mister, how many
Yes.
people are getting 100 on this test?
Not you, her.
Hi. So like on the problem that you're like
Wow.
the C, can you like simplify that before you start?
And that's what we shall do. Are you ready for C?
Yes, I
Oh.
am.
I'm
I'm
gonna-
so not like mentally prepared, but like yes.
I think I'm gonna zoom in a little bit.
Okay, Brandon, do you still need to write all the notes? Okay, so
This
you're
class is
I
such
think
a
I'm-
mess. I honestly get concerned.
I think
for
I'm,
us when we speak.
You can take a picture if you want.
Yeah, I'm good.
I don't like
I'm
that.
good.
I was like, did I not? want
That's
to?
scary.
Yeah,
Okay,
don't
ready.
erase.
I'm still
Oh.
recording. All right.
Don't knock
So
it.
Like you should from a column.
what I said before,
Yeah,
typically
put the time
I simplify from the inside out, okay? I think that makes it easier than simplifying from the outside in because you make it smaller and then you do the outside. Like, think about you get dressed inside and then you go outside. You don't go outside and then get dressed.
You don't know.
It's probably not a good idea.
What? Yeah, you do.
Sometimes I like stick my foot out and I'm like, is it cold? And then I decide what I want to wear. But other than that, I'm not just naked and walking outside. Okay, that's not a good idea.
I just
What
did
are
that.
you
You
Never
get yourself
naked. You
together
gotta wear
and then you go
underwear.
out. And remember, you're never fully dressed without a smile.
Well, I guess I've been running around naked this entire time.
Is 81 over 16 something that we can
You
simplify?
can divide by.
Nothing.
I don't
So
know.
you're not
What?
skinny dipping
You
if you're
can't.
smiling while doing it.
Trick question.
Trick question. So
Bum,
we're just gonna leave that.
I really thought that that problem was so much easier with
Everything you
numbers
wanted.
smaller.
Valid.
And everything
I
you
could
thought was a
shrink.
lie. Alright, look at the x's. Are
There
those
you go.
something we can simplify?
Yes. So
Yes.
x over x to the 2 at the top.
X squared at the top.
Oh.
Okay, remember the rule is you can subtract the exponents.
And then 14.
Okay, we got some y's. What about those?
So you subtract 1 from 15 and you get 14.
And where does it
He
go?
goes right on the bottom.
Right on the
That's where he
bottom.
wants to be.
It's where he likes to be.
Yeah.
Because
It's
if you put him on the top, he's negative, and
Poor guy.
nobody likes a negative Nancy.
Or Debbie Downer.
Now-
Oh, that's offensive to all the Nancy's. Huh?
How
I
many
don't know
Nancy's do
any
you know?
Nancy's.
I've never met a Nancy in my
I
life.
Neither
do.
do I.
Right?
What's a Nance?
Nancy. It's a name.
It's a name.
It's a name.
Oh.
It's a name, Dum Dum.
I thought I was like.
What's his
I
name?
don't know any people my age named Nancy.
It's like
Wait,
a name.
Yeah.
who's? Oh wait, I actually do know a person named
Stop.
Nancy.
Okay, next. What I'm gonna do is we're gonna do the 1/2 power to the letters first. Okay, so what is x squared to the 1/2 power?
I don't know.
It's 1.
Yeah,
Sure
x to the 1.
Do I have to like write it all out or can I just like write it down?
No, I'm skipping that.
Okay, good, because that's what I'm gonna do when I do
Then
these
we
problems
have
in reality.
y to the 14th power
I think
raised
it's like
to the 1/2.
7.
7.
Okay, I'm getting something right.
Okay, now I'm going to do the numbers. Now remember, the numbers you have to actually do
9
math.
and 4.
So it's 9 and 2. Yeah, 9 and 4.
9 and 4. So you're
This
not
wasn't as bad as I
taking
thought.
half of them, you're taking the square root of them. Sometimes people confuse the rules with the exponents with rules of real numbers. They're not the same.
It's
Like you're actually square rooting 81 and square rooting 16. And there you go. Ta-da.
Well, hey,
Let's do the you try.
I don't mind looking at that one.
You
But
try looks easy.
Miss
So the
Rupp,
you try takes all that and
You
puts it
try the
together in
bottom.
one wonderful question.
Thank
As you say,
What is
Oh,
that?
No.
What
No, no.
That's
Oh,
gonna make
that's
it
it.
grow.
Not getting any
when we
closer to
cry,
that
except for
thing.
my
So again, we're gonna work from the inside out. Let's start with the numbers. So inside out, left to right. Do 2 and 8 simplify?
Yes.
Yes.
By 2.
By 2. So this one would cancel, this one would become a 4. So 4.
Wait, hold on. I need to write down this problem still. Oh, was it to the negative 1 or was that minus 1?
Yeah, it's to the negative 1. Yeah, so it says x cubed on top and then it says x to the negative 1 power. Now there's two ways of looking at this. You can do 3 minus negative 1, or he's sad down here. Let's just pop him up there and he can hang out with x cubed. And when they all hang out together, they become
X 4.
x to the 4th.
Is this how you play with your daughter?
Yeah, Math Mondays.
That's pretty.
Same thing with y. So we can do 1/2 minus negative 1/2, or this is a negative 1/2. We can just move him up here, and when 1/2 hangs out with another 1/2, they become
What?
A
So-
whole.
They become a whole. They
Come on.
become one. When two become one. Spice Girls reunion tour.
I need some love like I never needed love before.
Who is
Now we're
that?
gonna raise everything to the 4th power.
Thank God.
So x to the 4th is
16.
None
yeah
of my business.
y to the 4th, and then
Wait,
we have
you're
to know
multiplying, not dividing. I mean, adding, right?
correct.
Okay. 'Cause I feel like I'm gonna like.
Yeah. Then we need to do 4 to the 4th. So
Isn't that
16.
1,024?
yeah, we like did that.
The one we
earlier.
just did, like.
Or no, wait, that was to the 5th.
Wasn't that?
So it's gonna be
250?
512.
256.
Let's check.
Wait,
1,
512?
2, 3,
Wait,
4.
what?
What has four?
No.
This is 16.
Isn't it
This
256?
is 64.
It's 256.
For what?
Yeah, it is.
Yeah. It's
Matthew. What?
Double. Yeah.
Then do we make it x to the 4th too? Why do I have an x in the bottom still? What is going on right now?
Oh, I don't know. You remember he moved up.
I know.
He's
I
moving up in the
had him
world.
up there. I just had an extra one just like lying there at the bottom.
Wait, who's moving up in the
All right, now the U try is all kinds of
Oh,
fun.
my
So
I don't know.
That was